Every minute, millions in gold move through this controlled chaos. Let's go inside and see every stage.
Imagine one tiny grain of gold buried in this rock. Watch what it survives to become this bar. This is how dead rock becomes real gold bars, step by step, with nothing hidden.
At first light, the hunt for gold begins deep in the Earth's scarred and ancient skin.
Each load of ore is a gamble, a moving mountain of rock hiding flecks of precious metal. To the untrained eye, it is just stone, but chemistry and pressure have written gold into its fractures.
Here, expertise decides which rocks are worth the journey and which are left behind.
Precision drilling maps the invisible veins, turning raw geology into data and decisions. Every fragment is cataloged and traced. Nothing about this Earth is left to guesswork. Controlled force reshapes the rock, breaking the Earth's grip on the ore it has held for ages. In a few violent seconds, hard rock becomes fragmented feedstock for the factory of gold. Steel teeth and hydraulic muscle take over where explosives stop. Dozens of individual actions merge into a single, relentless flow of ore. Human hands still guide these giants, reading the land through gauges and instinct. From the depths of the pit, the ore begins its climb toward the world of machines. Before the factory can feed, the ore is shaped, blended, and staged. This is the gateway from mine to plant, where raw geology meets engineered control. From here, every stone is in motion, pulled into the mechanical bloodstream of the facility. Extraction and industry are now locked together, linked by belts that never stop. The ore leaves open sky behind and enters the engineered heart of gold production. Here, flow is buffered and leveled, turning the mine's pulses into a steady industrial heartbeat. Operators monitor every ton, ensuring transport remains efficient, safe, and continuous. Even here, material is carefully blended to keep the plant's chemistry stable and predictable. From open stockyard to enclosed handling, the ore crosses the threshold into tighter control.
Transport routes weave together, rock above, people below, each following set paths in a shared landscape.
Gas flow is not guessed. It is measured, recorded, and traced minute by minute. Human movement mirrors material flow, rotating crews to keep the system running around the clock.
Access is controlled. In a high-value operation, security starts long before the gold appears.
Some plants draw ore from multiple sources, feeding a central processing heart from miles around. Whether by belt, rail, or road, all material must eventually pass a controlled entry point. Even here, precision governs motion, smoothing surges into a predictable stream. Step by step, every mechanical decision moves the ore closer to liberation. Day or night, the route from rock face to factory never truly sleeps. Reliability in transport is guarded by constant inspection, adjustment, and planned intervention. The journey across the site ends here, at the point where rock begins to change shape forever. What began as a hillside of solid rock is now ready for its first true transformation. Behind these vibrating walls, the ore is broken down for the long industrial journey ahead. The entire site is guarded, because every gram of recovered gold carries both value and risk.
Outside, it resembles any heavy industrial site. Inside, every structure is part of a precise sequence.
Here, planning, safety, and reporting frame the physical work unfolding just meters away. Every shift begins with routine, checklists, gear, and the same familiar faces ready to step into the noise.
Pay close attention to the lockout tags and the sequence of the milling line.
Before machines start, people align on risks.
The site is laid out like a circuit board, each structure performing one essential function. Inside, raw rock will be ground down to a fine slurry, ready for chemistry to take over. From the outside, these tanks look ordinary, but their contents will shape pH, flow, and recovery.
The drill is now complete.
Safety is built into the site's architecture, places to gather if the routine is ever broken. Supplies move in as ore move out, a constant exchange that keeps the plant alive.
From above, the gold plant shows its full scale, carved into the landscape like a permanent machine.
To reach the core of the process, people cross above the same paths the ore and slurry will take.
The heart of the plant is loud, hot, and precise, every movement tuned to an exact throughput.
From outside structures to internal bins, the ore finally arrives at the point of true processing.
Even static storage is monitored. Too little or too much can disrupt the entire downstream chain.
Light, ventilation, and dust control make the difference between chaos and controlled industrial rhythm.
Beyond this point, the plant shifts from simple movement to selective separation, preparing the ore for its most important changes. Here, the first line of separation begins, shaking rock into organized streams of size. Fine material falls away, while stubborn larger fragments are sent back for further breaking. Before the ore can move on, hidden metal threats are quietly removed from the flow. Water and rotation strip away mud and impurities, preparing the rock for more precise work. Coarse pieces are separated for further crushing and grinding, while fine material becomes a controlled slurry stream. Even in remote ore bodies, unwanted fragments travel with the rock and must be removed. Each pass through these machines narrows the size range, shaping ore so it grinds efficiently later.
Recycling oversize ensures that only properly sized particles advance, saving energy at the grinding stage.
And carefully controlled water volumes both clean and classif, while every liter is tracked in the circuit.
Below the visible equipment, hidden pumps quietly drive the liquid side of the process.
Hydrocyclones act as rapid separators, sending coarser particles back for grinding and fines forward.
After crushing, washing, and sorting, the ore is finally ready to be ground into slurry. Not every ton makes the cut. Some material is cleaned, drained, and sent away as permanent waste. Every separation step creates residue, carefully managed while the valuable fraction moves inward. Water, like ore, circulates in loops, cleaned and returned to support the next passes of washing. Regular checks on these surfaces prevent leaks of oversize or trash that could choke the downstream process.
With cleaning and sorting back online, the circuit resumes its steady preparation of feed for the core process.
What enters here is no longer just crushed rock. It is a carefully prepared feed, ready for the main transformation stage.
At this scale, grinding is less like milling and more like controlled, continuous rockfall inside a steel drum. Every second, tons of prepared ore pass this point, crossing into a zone of relentless impact and abrasion. Fines and slurry move forward, while stubborn fragments circle back, refusing to leave until properly broken.
Even within the core stage, material loops and recycles, chasing a target grind that unlocks the gold.
Where the sag mill breaks the rock, the ball mill refines it, squeezing the last coarse edges away.
Solid rock has become a flowing mixture, ready to be sorted grain by gravity and flow.
Classification closes the grinding loop, making sure only adequately ground material proceeds to chemistry. Here, solids are concentrated and excess water is stripped away, strengthening the slurry for leaching. What leaves this pipe carries concentrated gold-bearing solids, ready for the chemical stage.
Carefully controlled alkalinity protects the process, ensuring cyanide works on gold, not on unwanted side reactions.
Air, or pure oxygen, is introduced like breath into the slurry, driving the key reactions forward. The ore's structure is gone. What matters now is surface area, concentration, and time in solution. Inside these vessels, chemistry takes over, dissolving gold out of the finely ground ore.
Powerful reagents are handled with strict controls, delivering measured doses to extract the precious metal.
Each tank is a step in a long chemical corridor, tuned so that gold steadily transfers from solid to liquid.
In parallel with leaching, gravity devices seize free coarse gold before chemicals ever touch it.
High G-forces multiply gravity's hand, pulling dense gold grains into a tight, rich concentrate.
Residence time through this train is designed to let chemistry reach equilibrium and maximize recovery.
Having released much of its gold into solution, the slurry moves on to stages designed to capture and concentrate that invisible metal.
Here, the core of the process is represented as shifting lines and numbers, translating tons and reactions into decisions.
With gold now floating invisibly in solution, the plant is ready for the main transformation, capturing and turning it into tangible metal. In these tanks, activated carbon moves through the slurry like a silent magnet for dissolved gold. Carbon travels countercurrent to the slurry, picking up more gold as it steps back through the train.
Each transfer step shifts richer carbon backward, concentrating gold on the solid phase instead of in solution.
These screens prevent valuable carbon losses, keeping the gold-loaded media circulating where it is needed. Once saturated with gold, the carbon leaves the tanks, carrying a concentrated store of invisible metal. In this vessel, hot solution strips gold off the carbon, transferring value back into liquid form. Direct current drives dissolved gold out of solution, plating it onto metal surfaces inside these cells.
Over hours, thin ions become thick deposits, transforming invisible gold complexes into tangible metal.
Operators balance electrical power and time, tuning the cells for efficient deposition and purity.
When the cycle is complete, each plate carries a fragile crust of gold that must be carefully collected.
The plated layer is removed and gathered, forming a dense concentrate still mixed with impurities and moisture.
Filtration squeezes out liquid, leaving a semi-solid concentrate ready for smelting.
This is where chemistry and heat push the concentrate beyond its final barrier of impurities. Flux will combine with unwanted elements, allowing molten gold to separate cleanly as the temperature rises. At more than 1,000 degrees, solid cake and flux become a single, molten body of separated metal and waste. In seconds, liquid light is cast into solid form, each mold holding a future bar of crude doré. As the heat leaves, gold and silver lock into a new, transportable shape, doré. Each bar is marked, weighed, and entered into a strict tracking system from this point forward. Paperwork and digital records wrap around each bar, binding physical metal to its documented origin.
Before refining off-site, doré waits behind thick steel and layered security protocols.
Stripped and reactivated, carbon re-enters the circuit, ready to capture another cycle of dissolved gold.
Together, these units turn microscopic metal in slurry into solid bars of doré, ready for global markets.
The main transformation is complete, but increasingly, machines and sensors refine, stabilize, and safeguard every step.
Beyond these walls, high-tech automation takes the gold plant from heavy industry to finely tuned digital operation.
Here, the whole mine-to-metal process appears as moving numbers, colors, and trends under constant watch.
Every instrument in the plant reports here, turning scattered devices into a single, coordinated system. Sensors sit in harsh, slurry environments, sending silent, continuous measurements back to the control system. These racks form the nervous system of the plant, translating field signals into digital decisions.
One glance reveals the plant's health, where feed is strong, where circuits are stable, and where attention is needed. Automated analyzers continuously measure key chemistry, eliminating delays and manual exposure to hazardous solutions.
Algorithms learn the plant's behavior, making small, continuous adjustments that humans could never sustain alone.
Machine learning models track patterns over weeks and months, nudging the plant toward higher efficiency and lower cost.
Predictive maintenance tools catch subtle changes long before they become breakdowns.
Visual oversight complements process data, ensuring that people, vehicles, and material move safely. Digital diagnostics allow instruments to report their own condition, reducing guesswork and unplanned downtime. Complex sequences that once required multiple operators now run from scripted logic, minimizing mistakes. Even in an automated plant, layers of protection stand ready to halt everything in seconds if needed.
Connectivity extends control visibility beyond the central room, enabling support and analysis from anywhere on site.
Real-time grade data lets the plant respond quickly to changes in the ore, tightening control of recovery and reagent use. Instead of reacting hours later, the plant now tunes itself within minutes, guided by live data.
Energy, one of the largest costs in grinding, is tracked and managed like any other process variable. Behind the scenes, protected networks keep the plant's digital brain both connected and secure.
The past does not disappear. It is stored and analyzed to guide future decisions and upgrades. With automation stabilizing the core, attention shifts to the final touches, preparing each bar and shipment with exacting precision. Beyond this secure threshold, rough doré bars are inspected, measured, and prepared for their journey into the financial world.
Each bar's weight is captured with laboratory accuracy, forming the first line of its official identity.
A tiny portion of each bar is sacrificed so its true composition can be measured and certified.
Only bars with sound geometry and clean finish proceed, ensuring safe stacking and handling in vaults and transit.
Non-destructive testing confirms that bars are solid and free of hidden inclusions or tampering.
Digital records lock each physical bar to a unique data trail that follows it across borders and vaults.
With official marks applied, the once anonymous metal becomes traceable product recognized by markets worldwide. Behind this wall, classical fire assay and modern instruments confirm the exact gold content behind each stamp. For bulk shipments, bars travel in robust containers that can withstand both weight and distance. Tamper-evident seals and redundant checks create a chain of custody that can be audited at every step.
Consolidated on pallets, high-value metal now moves like any other warehouse load, but under far stricter control. Within thick walls and under constant surveillance, bars wait in numbered positions for instructions to move.
Digital ledgers mirror the physical stacks,
ensuring that every ounce of gold is accounted for at any moment.
Behind smooth bars and sealed boxes lies an entire layer of scientific validation that proves the quality of every shipment. Even small irregularities are recorded. In a world of heavy bars and tight stacks, edges and surfaces matter.
Prepared with precision, each pallet now stands at the boundary between the controlled factory and the broader logistics chain.
With digital confirmation complete, the finished metal is ready to leave the factory's inner core and step into storage and
Beyond this threshold, gold bars join the broader flow of industrial logistics, tracked and guarded from rack to truck.
Away from the noise of mills and tanks, the lab turns samples into numbers that define the plant's performance.
Tight control of pH and cyanide not only drives gold recovery, but protects workers and the environment.
Oxygen measurements confirm that the leach tanks have enough oxidant to keep gold dissolution moving forward. For gold content, the oldest and most trusted technique remains fire assay, refined but not replaced.
At near-white heat, flux, lead, and sample combine to isolate precious metal from the rest of the matrix. Each bead's final weight reveals how much gold was present in the original ore, solution, or doré.
These microscopic numbers scale up to daily metal balances worth millions of dollars.
Mass and metal balances confirm whether the plant is truly capturing the gold that geology and processing promise.
Tailings assays reveal what is lost, guiding optimization and ensuring that economic gold does not slip away.
Beyond recovery, the plant must prove that its solutions meet strict environmental and regulatory limits.
High-precision instruments complement fire assay, tracking trace metals in solutions and refining streams.
Quality control samples act as the lab's conscience, revealing drift or bias before it compromises decisions.
Lab numbers and plant signals come together here, guiding where to adjust feed, reagents, or residence times.
Each day ends with a reckoning of numbers, ensuring that quality, efficiency, and compliance move in the same direction.
The finished gold now rests in an organized grid of pallets, each one representing a shipment measured to the kilogram and gram.
High-value metal does not travel in ordinary trailers. Armored vehicles and trained escorts stand ready.
And this is how modern factories produce gold from start to finish. Subscribe for more real factory breakdowns.